Hi guys, today we'll be going over the power rule for differentiation. So last video, if you recall, we went over differentiation by first principles. So if your equation f of x is equal to x cubed, we know that f prime of x will be equal to 3x squared. This was the example we went through last video. Now, if we look at another example, I won't go through all of the first principles, but hey, f of x is equal to x to the power of 4. I'll just tell you now the derivative is f prime of x is equal to 4x cubed. Now another one, say f of x is equal to 5x squared. F prime of x, so the gradient function or the derivative, is equal to 10 of x. Can you spot the pattern? So essentially, if you generalize it, say f of x is equal to x to the power of n. F prime of x will equal n times by x to the power of n minus 1. So say you were given f of x is equal to x to the 6th, f prime of x would be equal to 6 because n is 6, and then x to the power of 6 minus 1, which is just 6x to the power of 5. And this is the short way of differentiating any single term. Say f of x is equal to 7x squared. If I also tell you that f prime of x is equal to 14x. Think about the general pattern here. I'll give you another one. F of x is equal to, say, 8x cubed. F prime of x would then be equal to 24x squared. Now how did I do that so quickly? I'll show you. F of x, so this is just generalizing it. Say f of x is equal to a times x to the power of n, where a and n are any integer or fraction. So f prime of x would then be equal to a times n, so you bring down the power, multiplied by x to the power of n take away 1. So, if I give you an example, a question for you to do, say f of x is equal to 9x to the power of 6. What's f prime of x? Have a go. So, to find f prime of x, you would do 9 multiplied by 6 times x to the power of 6 minus 1, which is just 54x to the power of 5. And this is your gradient function for the curve, where f of x is equal to 9x to the power of 6. And this is called the power rule for differentiating. And it's a much quicker way to differentiate, much quicker than by first principles anyways. So if you were to apply what we just learnt, and you say go over a quadratic, so say f of x is equal to the general quadratic ax squared add bx plus c. What's the gradient function of this? Have a go, pause the video, and then I'll go over it. Okay, so for the first term, you bring down the power and multiply by the coefficient, which is a. So that's 2a multiplied by x, and then you do the power take away 1. And now to the next term, it's the same thing. So you do the power, which is 1 essentially, 1 times b to the power of, multiplied by x times the power, which here is 1, take away another 1, which is just 0. And then for c, the c just it's deleted. So when you differentiate a constant, it gets deleted and it becomes a 0. Now if you simplify this, you're left with 2a to the power of 2ax to the power of 1, but yeah, add b x to the power of 0. And as you know, anything to the power of 0 is just 1. Therefore, the derivative is just 2ax add b. So this is the derivative of a polynomial. Sorry, not polynomial, of any quadratic. And as you can see, it's really very easy to do. Okay, let's differentiate a quadratic. Have a go at differentiating this quadratic. Okay, so when you differentiate x squared, you multiply, so you bring the power down, 2, x times 2 take away 1, add 9 times x to the power of 1 take away 1, add 0, because the constant just differentiates into 0. Therefore, this is equal to 2x to the power of 1, add 9x to the power of 0, and as you know, anything to the power of 0 is just 1, therefore it's 9 times 1, which is just 9. Therefore, the gradient function is just 2x, add 9. Now it's exactly the same for cubics, quartics, quintics. So say f of x was equal to x to the power of 4, add 3x cubed, add 6x squared, add 8x, add 9. What is the gradient function? Have a go. Okay, so bring down the power. So that's 4x times 4 take away 1. Times x to the power of 4 take away 1. Add. The 3 comes down, so that's 3 times 3, which is 9. X to the power of 9x times, to the power of 3 minus 1. Add. The power comes down. 12x to the power of 2 minus 1. Add. Here the power is just 1. 8 times x to the power of 1 take away 1, add 0, because the constant, when differentiated, becomes 0. And if we simplify this, you're left with 4x to the power of 4 take away 1, which is just 3. Add 9x to the power of 3 take away 1, which is just 2. Add 12x to the power of 2 minus 1, which is just 1. Add 8 times x to the 0, and as you know, x to the 0 is 1. Therefore, this is just 8. Therefore, this here is your derivative. And you can use this expression to find the gradient at any point on x to the power of 4, add 3x cubed, add 6x squared, add 8x, add 9, by just plopping in the number which you're given. Alright, thanks for watching and good luck with your exams.